Hi everyone, my name is Monica and I'm a PhD student at the Cure Lab at BC Cancer Research Center in Vancouver, Canada. And this is going to be a summary video about our recently published paper titled Physician in the Loop: Active Learning in Radiology Artificial Intelligence Workflows, Opportunities, Challenges, and Future Directions. As mentioned, you can see our recent paper that was published in the American Journal of Roentgenology with the DOI link here. And if you're interested, there's also two editorial comments that are associated with this paper. As well, there's also a keynote talk by Rahmim called Physician in the Loop AI for Medical Imaging AI Breakthroughs and Bedside Impact. So if you're interested, please check out these two works. The use of AI models for radiology relevant tasks are becoming increasingly more relevant, and they can expand the impact of medical imaging on patient care, as well as help ameliorate some global radiologist shortages, as well as limited access to imaging. There's a lot of different possible applications of AI in radiology, for example, with image reconstruction or lesion segmentation, image generation, classification, and even scheduling and triage. So there's a lot of potential for AI in radiology. However, there are some important limitations in the development of AI for radiology. The firstly is that supervised learning models, which are traditional models, they require fully labeled and large data sets, which can be very time consuming and expensive to obtain. And secondly, there's data access and code restrictions amongst institutions, which can really limit the amount of data that are available for training these models. Our technique is to use active learning, which aims to produce these labeled data sets by identifying the most informative or uncertain data for human annotation. In this case, it would be annotation by a radiologist. Now, the potential benefits of this technique are that it could potentially mitigate these challenging labeling requirements and these data and code sharing restrictions amongst institutions by only needing these radiologist input for the most informative or uncertain data. In this way, it can reduce the human effort from radiologists in curating these data sets for training. This brings us to the concept of physician in the loop AI, as demonstrated by the diagram on the right. This conceptualizes the interactions between physicians and AI models. In contrast to models that may have been developed in the past, we want to focus on interactions being feasible, efficient, and especially being able to be integrated within these existing clinical workflows. And this process will be enabled by active and interactive learning, which allows these users or radiologists to contribute to the learning process of a model. So as an example, the radiologist could receive prompts by the AI model to review certain labels, and then the radiologist would provide feedback by accepting, rejecting, or modifying labels. These new labels would then be added to the training pool and the update of the model regularly by AI scientists, quality assurance, and IT staff, which would oversee this whole process. And then this whole process of the radiologists interacting with the AI model would happen within their existing clinical workflows as they are reviewing the cases. Now, the opportunities for Physician in the Loop AI are that it can enable development and deployment of AI models while avoiding the extensive labeling that's traditionally required by radiologists for training models currently. It can also enable the measurement of certain imaging features and enable outcome prediction models within the radiology workflow. For example, imaging features such as handcrafted radiomics or PET biomarkers and outcome prediction models that are based on these features typically require segmentation. And this has been traditionally done manually or can utilize some semi-automatic or automated methods that should still be verified by a physician. So this can be very time consuming, and in this framework, we may be able to decrease the amount of time and effort by the radiologist. And this whole framework would promote closer physician AI interactions, and it can also contribute to the development of foundation models. Now, these are models that are more generalizable and are trained on a large variety of data. And to enable the efficient curation of the data for these models, we could potentially use a physician in the loop active learning framework. Certain challenges exist. For example, training requires significant computational resources like GPUs, which would need to be acquired if the department does not already have this. We also need to promote the closer collaboration between radiologists and the other stakeholders, such as AI scientists and IT staff. And we also need to increase the training of radiologists, medical trainees, and all other related staff in deploying, maintaining, and using the model. And lastly, as with any medical AI, it has to comply with ethical and legal standards. This is a general overview of the potential future directions, but namely, we need to think about the assessment of performance across increased dimensions. So not only focusing on accuracy or traditional evaluation metrics like dice score for segmentation, for example, we should also think about how easy the tool is to use for radiologists and how much time does it save? Does it actually save time? These are all kind of questions that we need to kind of focus more on the user experience as opposed to just accuracy metrics. Secondly, we need to think about guideline creation as we move into the future and AI is increasingly used in radiology or even other medical specialties. We need to think about the proper guideline creation to enable the use of these models and the appropriate and use. And lastly, we can think about incorporating some novel methods such as large language models or even gaze tracking to even further facilitate the process of incorporating AI into the radiology workflows. Thank you.